Alright, here we go. 12.2, measures of central tendency. So, what is the center of the data, and what is the best way to measure the center of the data? And that's what we're going to be talking about today. So what we want to do is we want to be able to determine the mean for a data set. So this is one way of measuring the center. We want to determine the median for a data set. This is another way of measuring the center. We want to determine the mode for a data set, another way of measuring at least the frequency of a particular data point, and to determine the mid-range for a data set. So these are just 4 ways that we do it. Now, there are a few formulas for doing it, but we're going to use our handy dandy TI-84 today to help us calculate these one variable statistics. Alright, so I'll be bringing that in and out of the video and helping you out with that. Alright. Now, I did want to give you the formula for the mean. This is basically what a lot of people will call the average. Okay? But in statistics, we have lots of different ways of calculating the average of something or the center of something. So we want to be real specific about using the mean. But it is add up all the data values and divide by the number of values that are there, and that's how we calculate the mean, right? So if we look here, I do have a nice example, and so the example is calculate the mean for the youngest U.S. male singers to have a number 1 single, right? And so here we have 13, 13, 14, 14, 15, 16, 16, 17, 17, 17. And we want to calculate the mean. Alright? So here's what I'm going to do. I'm going to bring the calculator in just so that it's right here. Alright? So we turn it on. And these are statistics over here. So we're going to use the stat button. Now, before I use the stat button, I do want to clear out all the data that may or may not be in there. So I'm going to hit second and the plus sign, which is memory. And then number 4 is clear all lists. And I'm going to hit enter and just clear all the lists. And so this gets me ready to put in my new data. So I'm going to hit stat. I'm going to hit enter to go into edit. And I'm just going to edit this list right here. So I'm going to put in this value, 13, enter. Put in this value, 13, enter. Put in this value, 14, enter. Put in this value, 14, enter. Put in this value, 15, enter. Put in this value, 16, enter. 16, enter. 17, enter. 17, enter. 17, enter. So as you can see, we've put in 11 different values. And so now what I want to do is I want to be able to calculate the mean, right? So again, we're using statistics. So I'm going to hit stat. And then I want to calculate something, so I'm going to use my right D-pad and go over to calculate. And I'm going to calculate a one variable statistic. And so I'm going to hit enter. And you'll see one variable stats is on the screen. Now, one variable stats defaults to L1. That's where I put the data. So I'm just going to hit enter again. And now X bar is the mean. And so the mean here is 15.2. Right? So the mean is 15.2, okay, and that's from X bar, which means the mean. Alright, now what do some of these other things mean that are on my calculator, right? So of course X bar is the mean, the capital S small x is the standard deviation, which we're going to talk about in the next video. N is the number of data items, number of elements, items, numbers, data points, whatever you want to call it. You see the little down arrow. I use my D-pad and I just sort of scroll down. This will actually give me my min x. So my min x is my minimum value. I know it seems so weird that we would call it min. Sorry. I bumped the calculator. The MED is median. That's another measure of the center that we're going to use in just a second. So we're going to find it in just the same place. And the max x, that's our maximum value, as you would expect. So this is going to give us our mean, our median. It's going to give us a way to get our range, the maximum minus the minimum. It's going to give us a way to get our mid-range, the minimum plus the maximum divided by 2. In the next video, it's going to give us our standard deviations. And in a regular stats class, the Q1 and the Q3 would be your interquartile range. So you get a lot of valuable stuff from just this one calculation here. Okay, so don't forget that. We're going to use it a couple of more times in this particular video, and then you get a chance to practice on it with your homework, right? So now, sometimes we have a value that shows up more than once, and so it has a certain frequency, okay? And so when many data values occur more than once and a frequency distribution is used to organize the data, we can use the following formula to calculate the mean. So the mean, which is x bar, is going to be equal to that value times its frequency, all summed together divided by the total number of values. Now you may be thinking, well, what is a frequency distribution? Well, this is a frequency distribution, right? So we have stress ratings. The stress ratings go from 0 to 10, 0 being not stress at all, 10 being the most stress you've ever experienced, right? And so several people, too, said they had 0 stress. 16 people said they had 4 stress. And so the frequency at which people reported this particular stress rating is over here. So this is a frequency distribution. And this is a great way of doing this, okay, and organizing this data. Now, how am I supposed to calculate the mean when I have 2 lists of data? I wonder what I should do here. Well, again, we're going to use our calculator, and I'm going to use second plus sign, which is memory. I'm going to use number 4 to clear all of the lists, and now I'm going to go back into stat and enter, and I'm back in my L1 list. Now I'm just going to put each of these values in, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and I put them in. Now I'm going to use my right D-pad and go over to L2, and now I'm going to put in 2, 1, 3, 12, 16, 18, 13, 31. Aren't you glad that we don't have to enter in 8 26 times? That would be such a pain. 15 and 14. And so now we've got this. And what we do want to do is we still want to calculate the mean. So I still want to hit stat. I still want to go over to calculate. And I still want to calculate a one variable statistic. And so I'm going to hit enter. So everything is the same. But now this was in L1 and this was in L2. And so I need to tell the calculator that. And so above number 1 you'll see a blue L1. And above number 2 you'll see a blue L2. So I'm going to hit the second button, 1. And then comma, second button 2, so that I look just like this. And so what this tells it is the values are scored in L1 and the frequencies are scored in L2. And now when I hit enter, I'll see that the number of elements is 151. And of course, if you added all these up, that is exactly what you would get. And so now as I look at this, my X bar is 6.5 rounded to 1 decimal place. And so my X bar is 6.5. And of course, if I scroll down, I get my median is 7. And this makes me very happy because now I have a great way of using the calculator to help me figure out what my mean and my median is. Now you may be thinking, well, what is the mode here? Well, the mode is the most frequent value that shows up. And if you look, 31 is the most frequent value, and that goes with 7. And so the mode is also 7. So this is a fairly normal distribution because the mean, the median, and the mode are all very close together, and that makes us very happy because we can do it with our calculator. Don't leave the batteries at home. Okay, so what is the median? So, of course, the median is the data item in the middle of each set of ranked or ordered data. So this is really important. It has to be rankable or in order. And so it's the data item in the middle of the order. Okay? And so to find the median, you do have to arrange the data items in order. And then if the data item is odd, the median is in the middle of the list. And if the data is even, then the median is the mean of the two middle items of data. And so literally, if you have 1, 2, 3, 4, the middle of this is 2 and 3. So you add 2 plus 3 together and divide it in half. And you get 5 halves is 2.5. Just halfway between 2 and 3. So that's the median. And that's how you calculate it if it's even. Alright? But as you can see, the calculator does it for you. Alright? So, do I really need to take this list of data and put it in order to figure out what the median is? I could do that. I could put it in order from least to greatest and count it off. So it seems like the smallest one is going to be 7. Right? And then what's the next biggest looks like 13. And then 15. And then 25. 28, 34, 47, 59, 64, 68, 74. Right? So there's the data. So now I'm just looking for the center. So those guys are on the end, those guys are on the end, those guys are on the end, those guys are on the end. I have two values that are in the center. So I'm going to take 28 plus 34 and divide it by 2. So I go to my handy dandy calculator. Second quit gets you to the home screen. I'm going to put in, never mind. I'm just going to do the 28 plus 34 and hit enter. That takes care of the numerator. Divide it by 2 and I get 31, and so 31 is the median. Probably just as easy and maybe a little easier depending upon how long the list of data is, but if you just go second memory 4, clear all the lists, stat, enter, now I can just go ahead and put it in this order: 68, 74, doesn't have to be in order, 7, 13, 15, 25, 28, 59, 34, 47. And the nice thing is if you could mess up doing it by hand, but this way I think it's a little bit harder. We're going to hit stat button again, over to calc, hit enter. It's a 1 list, so I just hit enter again, and now you get the mean is 37 and the median is 31, just like we calculated. So this is a good way of doing things. Now, I'm just going to show you, there is a way of finding the median with a frequency distribution with this thing that they call a position value, where you take n and you do n plus 1 divided by 2 to figure out what the position is. But then you still have to add these guys all up till you get to that position. So it seems like, well, this is something you could do. It seems like it would be a whole lot easier to just do what we did in the calculator. All right. Now, why do we have two measures of the center? Okay, why do we do that? All right, so this is what example 7 is all about. Why am I using these two measures of the center? So let's look at 5 employees that earn $19,700 a year, $20,400 a year, $21,500 a year, $22,600 a year, and $23,000 annually, right? So you have 5 floor workers. And then the section manager, right, who's over these 5 guys, has an annual salary of $95,000. If you look, these guys are earning in the low 20s, and he's earning almost 100 grand. Okay, so what does that do to the mean when you have 5 guys that are making in the low 20s and you have one guy who's making a lot more than that? So again, what am I going to do? I'm going to slide this over, bring the calculator into focus, and I'm going to go second plus, and then number 4 is clear list, and hit enter. And now I'm going to go into stat, and I'm going to hit enter again just to go into the first list. I'm going to enter in each of these salaries: 19,700, enter 2,400, enter 21,500, enter 22,600, enter 23,000, enter, and 95,123,000, enter. And so those are all of these salaries in there. Second, over to calc, hit enter, and then it's just one variable, so I'm going to hit enter again. You can see the mean is $33,700. So the mean is $33,700. This is more than everybody but the manager makes. In fact, it's $10,000 more than what the highest guy makes, and it basically represents almost 50% more. That's a lot. So what's going on here? Why is that? Well, the mean is really sensitive to this outlier over here. Now let's see what happens when we scroll down and we look at the median. The median is 2250. If you look at there, the 2250 is, basically a little bit less than 3 of the salaries, a little bit more than 3 of the salaries, and is much more representative of what the average guy is making, without the section managers in there. And so this is a much better measure of the center, because the median is much more resistant to these outliers, data points, than the mean is. And so this is a much better picture of where the center is. So salaries and home values and things like that, where you could have one really nice house or one really high salary, will pull the mean around. It doesn't do it so much to the median. So this is why we have the 2 different values. Okay, 2 different types of center. Alright, so last we want to talk about is the mode. So the mode is the data value that occurs most often in a data set. If more than one data value has the highest frequency, and frequency is key here, right? It's the most frequent or the set of most frequent numbers. So in the frequency distribution, this is going to be the easiest way to find it. Then each of these data values is a mode. Alright, so as I look back at my last one, my salary, okay, none of the salaries is repeated, so there's no mode, okay? As I look at my frequency distribution, 7 showed up 31 times. That was the most frequent value, so 7 here was the mode. So the mode is just the most frequent value, okay? And then last but certainly not least, we have the mid-range. I never dealt with the mid-range much, so this is part of the book, and so I'm going to cover it. But, this isn't something we use very often, because the mid-range is super sensitive to outliers, because it takes into account the lowest data value and the highest data value. And usually an outlier, an extreme value, is going to be either the lowest or the highest, and so that's going to drag the mid-range around a lot. Okay? An example of that would be finding the mid-range here, when in 2009, the New York Yankees had the greatest payroll, a record $201 million. It's a lot of money. The Florida Marlins were the worst paid team with a payroll of $36.8 million. Find the mid-range for the annual payroll of the Major League Baseball teams. Now, I have no idea what the actual middle should be. I only have these 2 salaries, so I'm going to add up these 2 salaries, divide it by 2, and I'm going to get $119 million. I am guessing that most teams probably did not pay over $100 million, and so this $119 million is drug up by this extreme value of the New York Yankees. Okay? So that's it for measures of center. Thank you very much for watching.